Okay, so let's talk about rational powers. Okay, rational powers. So there are two conditions for rational powers. Okay, so here is the first condition. So nth root of a is a real number. Next time we will talk about complex number. Okay, we're taking square root of negative number. Then you cannot use rational power. Okay, so nth root of a is real, and then the second condition is m over n is positive. Okay, yeah. So m over n is positive. Then we have this definition. Okay, we have this definition. So denominator means root, and numerator means power. Okay, so let me repeat this. So a m over n's power, this means nth root of a, and then you got m's power of that. Okay, m's power of that. So denominator means root, numerator means power. So another order, so you can also write down m over n as you take power first, a to the m's power first, and then you take nth root of the power. Okay, nth root of the power. So there's no order in this definition. You can take nth root first, or you can take m's power first. Okay, yeah. So if this is not negative, if it's not positive, if it's negative, what you should do? You just use the definition of negative power, right? So if this is a to the negative nth power, just put it in the denominator. Okay, in the denominator. So later you will see some example. This negative sign just means you flip the fraction. Okay, flip the fraction. So this is the definition. Let's look at examples. Okay, let's look at examples. So 27 to the 4 over 3's power. Okay, 4 over 3's power. So what this definition means, 3 down here means cube root. 4 up there means 4's power. Okay, 4's power. So I like to take the root first to make a small number. Okay, so we take cube root of 27 and then 4's power of that. So what's cube root of 27? 3, right? So this is 3 to the 4th power is 81. Okay, is 81. Okay, so we just need definition of the rational power. Okay, the rational power. So next example. So we want to know 8 to the negative 4 over 3's power. Okay, 4 over 3's power. Okay, yeah. So from the definition, okay, from the definition. So first we look at 1 over the positive rational power. Okay, so now what's 3 down here means 3 means root. Just like the previous example, here means power, right? So this is 1 over, so cube root of 8 and then 4th power. So what's cube root of 8? 2. So this is 1 over 2 to the 4th power, so it's 1 over 16. Okay, it's 1 over 16. So this negative sign just means you put the whole rational power in the denominator. Okay, denominator. So let's look at one more example like that. Okay, one more example like that, because this is new, it's not easy. So 27 divided by 8 and then negative 1 over 3's power. Okay, 1 over 3's power. Okay, yeah. So now we get a negative sign, so we put everything in the denominator, and then we put a positive 1/3, right? Positive 1/3. So 1/3 means what? Cube root, and then first power. Okay, first power. So here is 1. So it's just cube root, right? It's just cube root. So what's cube root of 27 over 8? So it's 1 divided by 3 over 2. So what's 1 divided by 3 over 2 is 2 over 3. Okay, it's 2 over 3. Okay, so last step, this is 1 divided by 3 over 2, which is 1 times 2 over 3. So you got 2 over 3. Okay, 2 over 3. So there is another better understanding of this negative sign. Okay, of this negative sign. Negative sign just means you change the numerator to denominator, denominator to numerator. Okay, flip the fraction. Okay, flip the fraction. Okay, flip the fraction. So if you have 2 over 3, so you take negative sign, negative power just means 3 over 2. Okay, if you get 3 over 2, the negative sign of that, negative power of that is just 2 over 3. Okay, 2 over 3. You change numerator to denominator, denominator to numerator. Okay, numerator. So this is the basic definition of rational powers. Okay, so let's look at one more example. 9 over 4 to the negative 1/2 power. Okay, 1/2 power. So this negative sign means flip the fraction, right? Flip the fraction. So it's 4 over 9 to the 1 over 2's power. Okay, so this means what? Square root of 4 over 9, so it is 2 over 3. Okay, 2 over 3. So flip definition is easier. If you follow the definition in the book, the calculation is longer. Okay, because you have to put everything down here in the denominator. And then you got 1 over square root of 9 over 4. So it's 1 divided by 3 over 2. And then you flip it, you got 2 over 3. Okay, 2 over 3. So you can flip first and then take rational power. Okay, take rational power. The purple one is easier. Okay, purple one is easier. So now let's look at some properties. So go over some properties of powers. Okay, powers. So before rational power, there are 4 definitions, 4 properties or definitions, right? A to the m times a to the n. This is sum of the exponent. And then a to the m divided by a to the n. This is the difference, right? Difference. And then we have a to the m times n. So this is power of a power formula, right? The last one. So a to the negative n is 1 over a to the n. Okay, 1 over a to the n. So these are the old properties about powers. Okay, about powers. So now they're also true for rational numbers, right? Rational numbers. So let's look at some easy examples. So here we have x to the 3 over 2's power times x to the 2 over 7's power. Okay, so now by the first root, right, by first root, by 1, we need addition, right? 3 over 2 plus 2 over 7. So now we need common denominator to add them, right? To add them. So they multiply by 7, 7, they multiply by 2 and 2, right? Yeah. So we got 21 over 14 plus 4 over 14. So the answer is x, and then 25 over 14's power. Okay, 14's power. So these properties are true for rational power and integer powers. Okay, integer powers. So one more example. X to the 3 over 2's power, and then to the 4 over 5's power. So this is power of a power. So we need product rule, right? Product rule. 3 over 2 times 4 over 5. So this is 12 over 10's power. But you cannot put 12 over 10 in the webwork, okay? You have to simplify the fraction. So this is 6 over 5 divided by 2, okay? Divided by 2. So it's x to the 6 over 5's power, okay? X to the 6 power. Okay, yeah. So some other examples like this. So let me write down a harder example. Okay, harder example. So 9 s to the negative 6 power t squared divided by 27 s to the 6 t to the negative 2's power. And then the whole thing raised to 3 over 2's power. Okay, 3 over 2's power. Okay, so if you have this kind of example, what you should do, you should simplify whatever inside first, right? Whatever inside. Sorry, I write down the wrong question. So the whole numerator goes to 3 over 2's power, and the denominator goes to 2 over 3's power. Okay, they're different. Okay, they're different. So now let's look at the numerator separately. Okay, numerator separately. So we have 9, 3 over 2's power. And then we have as negative 6, 3 over 2's power. And then we have t squared, 3 over 2's power. Okay, so we have 3 parts on top. Similarly, we have 3 parts on the bottom, 27, 2 over 3's power. As to the 6, 2 over 3's power. And then t negative 2, 2 over 3's power. Okay, 2 over 3's power. Okay, yeah. So now we can simplify each part, right? So 9, so this is what? This is second square root and then cube. So this is 27, right? 27. So that is 27. And then this is negative 6 times 2 over 3. So this is s to the negative 9's power. Okay? And then t, so 2 times 3 over 2, t cubed. Okay, t cubed. So this is also a multiplication. Okay, multiplication. Okay, denominator, this is cube root and then second power. So this is 9. And then 6 times that. So it's s to the 4's power down here, right? 4's power down here. And then t, negative 2 times that. So this is t negative 4 over 3's power. Okay, over 3's power. Okay, yeah. So now let's delete this. Put it up there. So now we need subtraction, right? We need subtraction. Division is subtraction. So subtraction. So for this 27 over 9, we have to keep it. So now let's move it here. And then as we have negative 9 minus denominator 4. And then t, we have 3 minus, this is negative 4 over 3. Okay, over 3. So the answer is, this is 27 over 9 times s to the negative 13's power. And then t to the what? 13 over 3's power. Okay, 13 over 3's power. You just add the exponents, right? Add the exponents. Okay, so this is one direction. Okay, one direction. So you have a number, and then you have rational powers. Okay, rational powers. And then we change rational powers to radicals to get easier number. Okay, to get smaller numbers. So another case is if you are given radical, we want to change it to rational powers. Okay, rational powers. So let's look at one example. First example, cube root of x to the 8. So how can we change this to rational power? So remember, denominator is the root, so here is 3. Numerator is the power, so here is 8. Okay, so let's write down this again. This is the root, this is the power. Okay, so number 1, we change radicals to rational power. Okay, so example 2, so let's multiply this. 4th root of 256 g cubed y cubed times square root of 256 g cubed y cubed. Okay, yeah. So we take the roots separately and then change roots to rational powers. Okay, rational powers. So 4th root of 256, and then we have 4th root of g cubed, 4th root of y cubed times square root 256 square root of g cubed square root of y cubed. Okay, y cubed. So now what's 4th root of 256? Is 4, right? So this is number 4. And then we have rational power 4 over 3 because 4th root, right? So it's 3 over 4, right? 3 over 4. Okay, yeah. And letter y, so here is 4th root, so it's 3 over 4 times square root of 256, 16. and the square root of y cube, g cube, so it's g square root, so it's 3 over 2. Y square root, so it's 3 over 2. Okay, 3 over 2. So now 4 times 16, 64. And then g, 3 over 4 plus 2 over 3. 3 over 4 plus 3 over 2, right? 3 over 2. So this is 9 over 4. And then y, you got the same power. Okay, so here note, we have 3 over 4 plus 3 over 2. So this is 3 over 4 plus 6 over 4, common denominator. So we get 9 over 4. Okay, 9 over 4. So we add the exponent for y and g. Okay, y and g. Okay, so now let's look at another one, number 3. So we want to simplify this expression, right? Cube root 8 x to the 7 y to the 16 divided by cube root of 27 x to the 4 and then y. Okay, and then y. So now everybody has cube root. Okay, everybody has cube root. So one solution is we take cube root of these 3 terms on top separately, right? And we have cube root of the bottom numbers, x term and y term. Okay, y term. So now cube root of 8, 2. Cube root of 27, 3, right? And then we use rational powers for letters. So x, this is 7 over 3 because cube root. Y is 16 over 3 cube root. And then the bottom, x is 4 over 3 cube root. Y is 1 over 3. So we got 2 over 3 and then subtractions. X, we have 7 over 3 minus 4 over 3. Y, we have 16 over 3 minus 1 over 3. This is 2 over 3, x, and then y to the, this is 1. That's why 3 over 3 is 1, right? And this is 15 over 3, so it's 5. Okay, it's 5. So we can use rational power and then operations of rational numbers to get a good answer. Okay, to get a good answer. Okay, so 2 more exercise. Number 4, radical x cubed y to the 5th cube root of x to the 5th y squared, and then 5th root of x to the 5th. Okay, x to the 5th. Again, we change them to rational power, right? So this is x 3 over 2 because square root, and then y 5 over 2 square root, and then x 5 over 3 cube root, y 2 over 3 cube root, and then the last one, x 5 over 5's power. Okay, 5 over 5's power. Okay, yeah, and then we can add them, right? For x, this is 3 over 2 plus 5 over 3 plus 1. And then for y, this is 5 over 2 plus 2 over 3. Okay, so x, this is common denominator 6, right? We need 6, so they both multiply by 3. So this is 9 over 6 plus 2 times 3 and 3. Here times 2 and 2. Here times 6 and 6. Okay, times. So this is 10 over 6. This is 6 over 6. So we got x. This is 25 over 6 times y. So here also 6 common denominator. So 3 here, 2 there. This is 15 over 6 plus 4 over 6. So this is y 19 over 6 power. Okay, 19 over 6 power. Okay, yeah. So that's change radicals to rational power. Okay, rational power. Okay, and our last example. So last example, some questions in the web work, there's a very big number, right? 125 h to the 4, and then s negative 2 divided by 5th root h to the negative 9 s to the 9. Okay, s to the 9. Okay, yeah. So now the problem is fifth root of this number, right? When you rewrite this, this is fifth root of 3125, fifth root of h to the 4, fifth root of s to the negative 2 divided by fifth root of h to the negative 9, fifth root of s to the 9, right? S to the 9. So now you change the others to rational power. So what is fifth root of 3125? So it's 5. Okay, it's 5. Okay, yeah. So 5 times 5, 25, 25 squared, 625 times another 5 equals 3125. Okay, so this is 5 times h, so 4 over 5's power, because fifth root, right? S, negative 2 over 5's power, divided by h, so here is negative 9 over 5. S is 9 over 5. And then subtraction, right? This is 5. H is 4 over 5 minus negative 9 over 5. S is negative 2 over 5 minus 9 over 5. So this is 5. H is 13 over 5th power, and S is negative 11 over 5th power. Okay? Over 5th power. So you can change radicals to rational power, or you can change rational power to radicals. Okay? To solve the problem. So you should work on 7.5 on the web work. Okay? 7.5 on the web work. About rational powers.